Okay, so today we're going to learn what a function is. You can think of a function as kind of like a machine. You put something into one side and it makes something into something else. You don't really necessarily know what's happening to it, but as it moves through, it changes. So you have the input, or what we call x, going in on one side, and the y, or the output, coming out on the other side. A function is where you know exactly what you're getting out. So that means whatever the input is has the same output every time. Now what that means literally is each x has only one y. If each x has only one y, then it is a function. If there's an x that has two different or more than two different y's, then it is not a function. Now, there's a couple different ways that you're going to see a relationship. The first way that you're going to see a relationship is called a mapping. It gives you a list of two sets of numbers, and it shows you the relationship. It says that 2 turns into a 1, 4 turns into a 3, and 5 turns into a 2. Okay. Now I can see also that these are my x's and these are my y's. So I can see here that each x only has one y. So this is a function. But now when I look at this other mapping, I'm looking at the same thing. It's going to show me the relationship between x's and y's. And now, on this one, I see that 2, the x of 2, could actually turn into a 1, or it could turn into a 3. That means that one x value has more than one y value. So, because of this right here, it makes it not a function. And just another side note, that if you see one where there is more than one x that points to the same y, that is perfectly fine. There's nothing in the rule that says that two different x's can't have the same y. So this is still a function. The rule is each x can have only one y. Now, another way that you'll see a relation given to you is in a table. A table is very similar to a mapping, except for it always just maps straight across. There's no, the arrows can't ever cross or anything like that. So the x is 4 is the same as y is 6, and the 7 and 10 go together, and the 6 and the 11 go together, and the 8 and the 3 go together. Okay, and as you see, each x only has one y. So this is a function. You can also notice that since x didn't repeat, there was no way for the x to have two different y's. But as you notice on this next one, there is two different x's that are 1's, and both of those 1's have a different y value. So if you put in a 1 for x, you might get a 7, you might get an 8. You don't know what you're going to get. That's why it's not a function. Okay? The definition of a function is you know exactly what you're going to get every time. So when you put in an x, you get exactly one y value every time. So each x has only one y. Now, the next way you'll see it is written as coordinates or points. Again, this is very similar to the table because you can see that the x and y go together. On the first point, x is 8, y is 2. The next point, x is 4, y is 3. So you can see very easily it's just like a table. And you can see very quickly that none of the x's have more than one y value. In fact, none of the x's even repeat. The first thing you look for is an x repeating. And if it doesn't repeat, then it can't have multiple y's. Okay? Now, you might notice and be thinking, hey, what about those 5s? They repeat. But those 5s are y's. It's okay for y's to repeat. Y's can have as many different x's as they want to. Doesn't matter. Okay? But the x's can only have one y. Okay? That's why this is still a function, because those 5s are y's. It's okay for them to repeat. Now, if we look at this one, we get 4 points again. Again, we're reading it the same way we read the table, same way we read the mapping. The 6 and the 3 go together, the 1 and the 4, the 6 and the 2, the 8 and the 3. And you should notice that that 6 went with the 3 and the 6 went with the 2. Well, that 6 is in the x's spot, so it can't have two different y's. So this is not a function. Okay, now the last way you will see a relationship is on a graph. Now the graph could be just a bunch of points, it could be a line, a curve, doesn't matter. Okay? But we test a graph by using the vertical line test. Now, why is a vertical line important? Well, as you notice, these 2 points are right above each other. Well, any 2 points that are directly above each other have the same x-coordinate, or they wouldn't be in the same spot on the x-axis. And they have to have different y-coordinates, otherwise they'd be the exact same point. So if you have 2 points that are directly above one another, then that means they have the same x and different y's. That means it's not a function. So the vertical line test is very easy. If you can draw any vertical line through the graph and it touches it more than once, it's not a function. So even if I have a line like this, it's curved all over the place. Oh, there's a vertical line, touches it more than once. That means that's not a function. Okay, and one more example. If I've got this curve, well, there is no vertical line that I could draw that would touch that graph more than once. So since the vertical line wouldn't touch it more than once, this graph is a function. Okay, now that we know what a function is, we need to practice function notation. Now, function notation looks like this. And this says f of x, not f times x. This is one symbol together. You can't separate it. You can't divide by x to move it away from the f. Okay, it's f of x together equals 4x minus 7. Now, this would be given to you in a problem. And then you would be asked to find something like f of 5. Again, just like the f of x, this is not f times 5. This is f of 5, and it's one symbol stuck together. You can't separate it. Okay? So, to do this, you notice that the 5 is right where the x was. So I'm going to take that 5 and put it right where the other x is. And I get the other side of the equation. 4 times 5 minus 7. So that lets me know that f of 5 equals 4 times 5 is 20 minus 7. So f of 5 equals 13. And 13 is my answer. Notice, I still have f of 5 over here. I didn't move the 5 to the other side because that's part of the f. My answer is 13. My answer is on the other side. I still have f of 5 over there. All I did was put the 5 in for the x and solve for the answer. Okay, I'll do one more. I'll even do it with, I'll call this one g of x. Now, that's just naming it a different thing. The first function was named f, this second function is named g. That's really irrelevant. It doesn't really matter what you name it. Okay, so g of x equals 14 plus 3x. And we're going to find g of 4. So that means I need to plug in a 4 where the x is, so 14 plus 3 times 4. That means g of 4 equals 14 plus 12. So I know that g of 4 equals 26. And that's it. That's all you have to do for function notation. Plug in whatever they put where the x is, you plug that in where the x is, and find the answer.